Alright, party people, let me hear some noise. We'll continue part 5, then we'll jump for some joy. So this is becoming pretty straightforward, pretty old hat, if you will. So this one I think actually comes pre-marked, so it's really just a matter of setting up the equations. If we want these guys to be congruent, we're looking at 2x minus 3 equaling 12. I know that actually because those sides are marked to be that. And then on the inside, I have some angles. I have a 4y minus 9 and a 10, and those again are marked to be congruent. That's what those little arcs mean. So we have 4y minus 9 is equal to 10. Let's just solve these guys out. So over on the purple side, the side lengths, we have 2x minus 3 equals 12, which means 2x has to equal 15. So x is going to be 15 over 2, 7.5 if you want to make it a decimal, but you don't want to do that. Over this guy, that's purple, I think, actually. So we have 4y is equal to 19. Therefore, y is equal to 19 over 4. Or if you want to reduce that to a decimal, you're welcome to. I'm not because I don't have a calculator handy. So here is this guy. We're told quite a bit. So I'm going to actually mark my diagram up. We know hn is equal to 5. So that's 5. We have kn, this guy, which is 7. And then we have kh, right here, whoop, which is 7y plus 6. So now we just have to kind of match these pieces up, but we had to probably do a little bit more on the inside in terms of angles. So if I look at this triangle on the right, I can tell this guy is a 90 because of course linear pair postulate. If that's 90 and that's 32, this is going to have to be 58, otherwise they wouldn't add to 180 degrees. So now we have to do some kind of comparing. If I'm looking at these triangles, especially if I think about this triangle, if I were to rotate this with n as my center of rotation, that would make 5x minus 1 congruent to 58. Oh, excuse me, 5x minus 1. Okay. So if that's the case, we have 5x is equal to 59. So x is equal to 59 fifths. Hey, not a pretty answer, but honestly, who cares about pretty answers? All you care about is that you have the right one, and you indeed are. Now, the second part is going to take a little bit more finesse because all the information is within the same triangle, but it is a right triangle, which lets us use a Pythagorean theorem. Recall that a squared plus b squared is equal to c squared. So we have 5 squared plus 5x minus 1 squared is equal to 7y plus 6 squared. Hold on. Actually, let's go ahead and void this problem. I didn't anticipate this problem ending up in this set. If you want to see this one completely solved out, I can show you. That's not something I'm willing to show you um, right now. Although I do have this wrong. Excuse me. This should be 7 squared. Okay. Actually, let's go ahead and finish it. I changed my mind. I'm sorry. I realized I made a mistake. This actually is much easier than anticipated. But anyway, Pythagorean theorem. So this is going to be 25. This will be 49. This binomial squared will end up with 49y squared plus 84y plus 36. And from there, we're going to solve it. So I wanted to show you one more line. Let's leave it at that, though. I don't actually want to delve into that problem anymore. It's not worth the time. What's really important to me is actually these two equations. So as long as you came up with the equations, particularly this one here, that's really all I care about. Let's just move on. So again, we have values, want to make them congruent. Looking at the congruency statement, we have these pieces are congruent as well as these angles, which allows us up a couple equations. The first one is going to be 6x minus 5 is the same as 25. So that means 6x is equal to 30, x is equal to 5. And the second piece, which is going to be our angle piece, we have y plus 7 is the same as 25. Therefore, y is going to be equal to 18. Last one of this set, again, looking for congruent pieces. Where did I put it? There she is. Okay. Looking for congruent pieces. We have 14, 14. We have this 15, which should be the same as this 2y minus 10. Uh, we have this x value for angle, which we're not told directly, but again, you guys probably recognize this trick now. We have these two angles of a triangle, which are 68 and 32. Let's see, so that'd be 10, 100, right? So if these two angles add to 100, this guy has got to be 80, which helps set up our second equation. So we have 2, we have the side length, which is 15, is equal to 2y minus 10. And then we have the angle, which is 3x plus 12 is equal to 80 degrees. So now we just got to solve it. Let's solve the y first. So 25 is equal to 2y. So y is going to be equal to 12 and a half. And then over here we have 3x is equal to 92. So x is going to be equal to, and this one is improper fraction, 92 over 3. And of course, if a calculator you want to make that a decimal, you totally can. Okay, so a little bit more algebra. Again, just kind of find the congruent pieces on each one, put them together as an equation. This one, again, I apologize for this one. I didn't anticipate it getting quite this complicated. I guess I wasn't looking too carefully when I was picking problems for this set. I'm not too worried about the part that's in purple, so please don't get bogged down or kind of freak out about that. Let's just keep it to the setting up and solving of equations like this, okay? So that's what part 5. I'll see you guys part 6.